as I'm gonna do it right now, is that the thing which is gonna be done in the class is that all the lectures, as you know, from next week, today is Thursday, from tomorrow, which is gonna be, tomorrow is gonna be Friday, we do not have any class for the weekend, but for Monday afterwards, towards, I should say, the first week of the September, we are gonna have, I should say, 3-hour session per day. And I have arranged a kind of a plan that it doesn't make you bored. You're always engaged, but in a very positive way that you can, I should say, do not get bored because of having 3-hour sessions then that's a good thing. The second thing is that I'm recording all single minutes of the class. Then I'm gonna also share that on the course Schoology website. Then you can get the access. For example, if you miss a session, or let's say, for example, if during the class there was one concept that you weren't focused and you need to check that again, you have always the chance to go back to check the video that I recorded that during the session, and I post that video immediately after the class. And as you will see today, it's gonna be on the update section of the course Schoology website. Okay, and that's it. And that's a good thing that you can always have the access to the content of the class. And the other thing that I just want to tell you is that right now I have to just share my screen to show you something that I did that yesterday. And let me share my screen, go to the course website. Now everybody sees my screen, huh? Is it shared with you?
Yeah.
Awesome. Guys, look at that. We have also, there is one other course. I in the second half of the class, I would instruct you how to join into that folder of the class, because that folder, if, for example, for Laura who just wants to do the business, and also for, I should say, for Sylvia who wants to do something with the math in future, I'm sure she's gonna do great with the English, that she can get higher admissions with the good courses at universities. This folder is going to be crucial. You're going to learn a lot, and you will see what do I mean later. If you go to the course websites that we have for the advanced function tool, which we have, if you go to the course main page, you see these materials which I created it yesterday. Have you checked that before? Laura and Sylvia, did you check this page yesterday, which I created that on the course website? Laura and Sylvia?
Yes. Yes.
Check that. Was it okay? Did you see that course page? Then if you check that, you will see that we have a couple of folders. I created it. This one is going to be, I should say, the lesson plan, which I create every day. If you go to the course, good morning, Hank.
Hi, sir. Sorry, I'm late.
Day. If you go to the course website, you see that the first folder, which I created for you, this is for the lesson plans. If you click on it, you see two different lesson plans. The first folder is the regular lesson plans, which we have every day. And the other one is the thing that we do for the modeling. Because in advanced functions, we are gonna make sense of the functions that we learned from the functions 11, and we want to see how they are just gonna impact our daily lives and how we can see them around us. That's a good thing, that we are gonna work with the functions. That then as a result, that's what I want to mean, that you do not see the advanced function class as something like all the math. You get bored. You say, oh, I don't like to see, let's say, trigonometric function, finding the inverse of trigonometric function. But here you're gonna see a very cool applications and what can be done with those kind of functions. And that's the reason I have two different folders for the lesson plan. And at the end of the day, I'm gonna fill this with the lessons plans which we had today. Okay, the second folder, which is crucial, you are gonna work with that even today, is the second folder, which is called textbook. If you click on that folder on the Schoology website, you see the course textbook, which is the Advanced Function 12, the Nelson version of the book. You see that, guys?
Yes.
The Nelson version of the book. You click on it. If you click on it, you can save that book onto your desktop or folder, and you can get back to that anytime you want. It is going to be our reference material for the rest of the course. And that's the thing which we do. Okay, I'm going to go back to the main page. You see two other templates. You see two other folders. The second half of the class, you understand why you have these folders onto your course page. This is our codes template, which is still empty because we're going to fill this today. And also you have a folder, which is going to be the last folder, which is called the datasets. In the datasets, I have uploaded one data for you, which is weatherhistory.csv. Don't worry about that. If you do not understand what is this, we are going to go back to that tomorrow. I was a little bit, I should say, too early to put it there right now. But as a result, I just want to show you these ones. These folders are the folders that we start with. You are going to have more folders, for example, for your assignments or for your quizzes or for your final exams. I'm going to create another folders there as we move on, and you can get the access to those course materials from there. Okay, any questions so far? No questions yet? Okay. Now, as I said, at the end of the session, Anki, maybe you didn't notice that, we just said that bit before you joined. We said that every session's lectures, all 3 hours, or for today and tomorrow, which is 2 hours, are being recorded. And at the end of the session, you can get the access to that. And as you will see today after the class, I'm gonna post. If you go to the updates, you see a link which I put for the course. And that's where you can find the course materials for that day, which is recorded. And I share the link on the YouTube. You can click on the link on the update section at the end of the class when I post. You can get the access to the contents which is recorded. And that's pretty much everything before we start. Okay, any questions, guys? Nothing? Okay, now, the other thing which I'm gonna do is this. I'm gonna go to share my screen with the course textbook, which I have. Okay. Okay. And now this is a course textbook, which I have opened that into the PDF format. I clicked on the link, which is on the course Schoology website, saved it somewhere on my computer, laptop, or my PC, then I opened it by the PDF. Everybody has the access to the book now? And that's how the book looks like. And as you will see, today we start from chapter 2, because chapter 1 of the textbook is something which you have done that recently in functions 11. Then as a result, there was no point to just go over to review that. You're going to do that on your own time. But for the sake of the lessons that we are going to cover today, we are just going to start by chapter 2, and that's the starting point of the class. Then please, if you do not have uploaded and downloaded the textbook yet, please do it now. Then we just move on to the course step. Please save the book, go to the course website, save the book, and open that. Then we just start the text. Okay, now everybody has the book?
Yes.
Awesome. Okay, now I'm gonna, as you see, I'm just gonna start from chapter 2, which is talking about the functions and understanding the rate of the change. Okay. Before we start, we just go to the textbook. I'm just gonna start by sharing the whiteboard for the course. But before that, anybody has any questions? Chapter 2, the rate of change of a single variable function. Okay. Okay, now let me see. Yeah, I can just use that. Okay, guys, and that's gonna be the topic for the course. That's what we're gonna talk about. The chapter 2, the rate of change of a single variable function. Okay. Everyone sees the whiteboard which I have created? Yes? Guys, please be active. If I ask you questions, yes or no, please don't hesitate to say yes or no, because that's how you interact with me and it keeps me focused on the teaching which I have. Okay. And now, okay. Now, before, if you remember, previously we talked about a function. Oh, let me erase this. I didn't mean to use this one. I'm just going to use the drawing part, which is going to be this. And I'm going to choose the color. Let's say choose the color red. That's, now it should be fine. Okay. Now, if you remember in the function 11 course, we talked about the functions. Okay, when we talked about the functions, guys, what did we mean? When we talked about the function, we said that when we define a function, essentially we always come to say, okay, we have, for example, two regions. For example, there are two subspaces of the real numbers, if you remember. For example, I'm just going to start by a very simple example. We said that, for example, I'm just going to make some dumplings. Laura, do you like dumplings?
Yes.
Yeah? Okay. Now, for example, you just want to make some dumplings. And we said that we have two dishes. Essentially, that's how I'm just going to get to the point for chapter 2. We said that when you just want to create a function, that's the same like that. We say that we just want to create dumplings. We say, for example, Laura, what do we need to make dumplings as ingredients? For example, we need some pork, huh?
Yes.
We need pork. We have, for example, we need some salt. And for example, let's start with these two, I should say, with these two things. Then we said that here, we just want to, let's say, for example, at the end, we just want to have our dumplings ready on this side, which this is like the plate. But in order, you saw that, for example, if you, for example, today, you have some desire, you have some craving to make some dumplings for yourself, getting close to the weekend, you create these kind of ingredients, which is going to be, for example, pork, salts, and other ingredients, and you want to transfer them into some dumplings that it makes it ready to eat. You know? But in order to get from the pork and salt into something which you can have a dumpling, there are lots of things which happens. For example, you have to mix them together. You need a kind of a recipe. You have a recipe, which it means that, for example, you have 200 grams of the pork, salts necessary, you put them into the oven, and at the end, after 20 minutes, for example, you have the dumpling. Essentially, that's what you saw in function 11. You saw that the function is this, the recipe which we talked, we call that the function. You give some inputs, we call these ones inputs. You have the recipe, which is the function, and it gives you the outputs, which is essentially, this is the dumpling, which is ready for you to take it and eat it. And that's essentially what a function does. You give something to the f, and f changes it to something different, transforms it. In the context of a function, normally what we do is that we do not say normally change. We use a more fancy word in order to explain what the function does. We say that the function is essentially a recipe that transforms something from the domain of the functions into a range of the function. And that's what do we mean by the transformation of the function. Does it make sense to everyone?
Yes.
Yes, it's a kind of a review of the thing that we did on, let's say, on functions 11. And now, I'm just going to go something more fancier with the function, which is essentially, guys, Sylvia, Laura, and Anki. This is essentially going to be the building blocks for the functions, advanced functions for grade 12. And now, for functions 11, we saw the functions. Let me change the color to black. We saw functions in functions 11 that we talked. We saw functions as a transformation, which essentially what we can call function transformation. You saw that you can, oh, it changes the whole color. By the transformation, you saw that essentially in more elementary terms, we can call transformation as a change. That's what do we mean? That was something, a concept that we learned in functions 11 course that we saw. But however, now in functions 12, we are going to also still, as we still think of the functions 12 as function, as a transformation, we still think of a function as, or also as a transformation, but also functions as a modeling. Let me write it in that way. Function as a descriptive, in parentheses, modeling of nature. That's what I have written in, let's say, let me put that here, which is going to be our concepts in the functions 12. Then you will see that we have two different equivalent definitions for the functions. The first one, which we saw that in function 11, was a method for change. But today we talk about the function as a descriptive modeling of the nature. What do I mean? For example, you also talked about that thing also when you were working in, let's say, in functions 11. We talked about, what did we talk about? We talked about, let's say, for example, in function 11, we talked about bacteria mitosis. Do you remember that in function 11? In function 11 that you talked, we said that for a bacteria mitosis, I'm going to ask Anki, Laura, and Sylvia, did you see that concept in function 11? You have one bacteria, it starts to grow exponentially. Did you see that?
No.
No?
No.
Oh, okay. Then let me erase this, then go with something different. I'm going to talk about that. Maybe this term, I'm going to show that bacterial mitosis, this term, but then as a result, then I change my example to something different. Okay, now, look at this. I'm going to give you one example. I'm going to draw, let's say, a chart. In the chart, I'm going to say, okay, for example, it's going to be hours. And on the other side, it's going to be my income. Look at me as a teacher with someone who the way which they pay me, the way, guys, the school pays me, it's based on the hours which I teach you. It's not like the fact that I stay at home, they pay me money. I have to teach you based on the hours, then they pay me. What do they say? You say that, okay, based on the hours which you, for example, which you teach, you are going to get some incomes. For example, they say that if you get 1 hour, we pay you, for example, let's say, for example, $10, for example. If you teach, for example, 2 hours, we pay you, for example, let's say, $22. If you teach 3 hours, we pay you, for example, let's say, $35 total. For example, Mr. Andrew, which is the principal of that school, he designs this way that it shows the income which I get. Then at the end of the day, I come to find what is going to be the income which I get, because the problem is that, guys, imagine that I'm married and I have some kids, then I have to make some kind of predictions, then how much income I may get, let's say at the end of the July, because I have to pay for my rent, I have to pay for my mortgage, I have to pay for my mortgage of the car, lots of things I have to pay for it. I have lots of bills. Then as a result, I have to be able to see what's gonna happen in the future. You know, what is gonna be my income, let's say by July the 31st, if I teach the total of, let's say, for example, 40 hours for your class. Does it make sense to everyone? What do I mean?
Yes.
Yeah, then I can just come to my wife and I say, darling, I'm gonna have this much income, then we are okay to pay the rent. Or I'm gonna go to her, say, okay, I'm short of this, I'm just gonna, for example, I have to take more hours then in order to do that, imagine I'm gonna define one single variable. I'm gonna call that x. I'm gonna call this a single variable. Let me variable. This single variable represents what? Represents the hours which I teach. And also, I come here to define something, called it y. It becomes what? Becomes my income. Right? And now, the model which I can say, okay, the model which I'm just gonna propose when I'm gonna, okay, to predict my income is gonna be this. I'm gonna say my income, which is a function of the x, is gonna be what? Is gonna be, let's say, for example, it's gonna be 10 times x plus, let's say, 5. Let me highlight this one because there is a lot to talk about this before we move on. Look at this one. What I have done here, I have done some modeling. Oh, my handwriting is horrible. I have done some modeling. What do I mean by this modeling is this? I mean that, for example, imagine that x represents what? X represents the number of the hours, which I defined that here for you. X is gonna be the number of the hours. For example, guys, how many hours do we have for today?
Oh, sorry, how many what?
How many hours do we have for teaching today?
Maybe 6 hours.
Oh, for today we have 2 hours. I have 2 hours for you. We start from 11 till 1, that's right?
Yes.
Then I'm gonna teach you 2 hours today. Guys, I'm just gonna bring some cool materials for, I should say for teaching. Give me 1 second. I'm just gonna, I come back in a second, bring some stuff. I come back in less than 2 seconds. Stay there, I bring something for the teaching there. Stay there, please. I come back in 2 seconds. Okay, sorry guys. Yeah, Laura, then what we said was, how many hours do we have for today's class? We have 2 hours for the advanced function, huh? Then,
Yes.
guys, are you there, everyone? Sylvia, Laura, and also,
Yeah.
yeah, everyone is there? Yeah. Look at that. For example, I have 2 hours today. Then it means that my income for today, let me change the color. It means that my income for today, I write it V for today. Y for today. Oh, my handwriting is a little bit terrible with these kind of softwares. I say my income, which is represented by the Y, I have it denoted here today. It means that my income for today, it becomes f, the function. What do I have to put for x today? What do you guess? Becomes 2, huh? Because x represents the hours. Look at this. X, my single variable here, represents the hour. Is it correct?
Yes.
Okay, super. Then look at that. Then I say that, okay, if I teach 2 hours, then if I say to my wife, how much income do I have? I put 2 inside the function, which becomes 10 multiplied into 2 plus what? Plus 5. How much it becomes? 10 times 2 becomes 20, plus 5 becomes how much?
25.
That's so correct. Thanks. Then it becomes $25 that we have to, let's say, that I'm gonna earn today. Then when I go back home today, I say to my wife, she asks me, Omid, how much income do you have for today? I say, oh, darling, I have, let's say, I measured it, then the total income which I'm gonna get is gonna be $25, my total earning for today. And you see, that's the modeling which I did it. Let me go to the next page. Any questions, guys, so far?
No.
No? Okay. Okay. I'm just gonna rewrite that again. My income as Y was a function of the X was 10x plus 5, correct? That's my income. I'm going to ask you 2 interesting questions. Guys, if you accept that this model represents my total hourly income of teaching, we saw that if I teach 2 hours, I put X, 2, then I have $25. Then my question for you is this: how much is going to be my income if I do not teach you today? For example, you are waiting for me in the class, then I do not show up. Then am I going to get paid for it or not? What do you think, guys?
You get $5.
That's so true. Thank you. You say if you put x equal to 0, then y, which in it shows my income for today, becomes essentially the recipe for x equal to 0, then I put x equal to 0 times 10 becomes 0 plus 5 becomes $5. Life is going to be very easy, huh? I do not work at all, but I get $5. Isn't that funny? then that's what I get. Guys, before we move on, I want to take care of the thing that we mentioned today, which is the interpretation of the $5 which I got when the x was 0. We call this what? We call this intercept. Intercept. Have you seen that in functions 11, that terminology?
Yes.
Okay. This is called intercept. And you see that the interpretation of intercepts for my case is that how much do I earn if it do not work at all? I do not come to the class, but at the end of the day, I expect that the principal of your school pays me. And that's what does it mean, the intercept. The other thing which I just want to show that to you, which is gonna be predictive power of the model. The other thing which I'm gonna talk to you about that for the model that we talk is gonna be the concepts of the prediction of the function. Look at that. For example, what do I mean? I mean that, for example, guys, look at that. I told you I have to pay some mortgages because of my house and my car. Then I have to make some plans. I have to make some budgets. I have to make some plans to see if my income from teaching your class is enough that I can pay my mortgage. Then what do? I say, okay, I'm gonna make some prediction to say, okay, what happens if I teach 40 hours? Okay, let's say 40 hours for your class for this week. I mean, if X, the number of the hours which I'm teaching you, is gonna be 40, then what is the prediction of my income? I mean, Y predicted becomes how much? Becomes 40 times 10 plus 5. How much I do expect to get? $405. You see, that's the predictive power of, let's say, of the mathematical functions. That sometimes it allows you to make some prediction. You see? And that's the importance of the predictive power of mathematical modeling. It allows you, when you define a natural phenomena, for example, like the basic example that we had, then it gives you what? Then the mathematical modeling, the mathematical function, which models an event, may give you predictive powers. What does it mean? You can see what's gonna happen. You would see what may happen in future. That's the core thing that we learned from the example which I told you. Okay. Any questions, guys? So far?
No,
Nothing?
no.
No. Okay. Now, we move on to something very quick. Then we take a break. Then we come back to do some exercises. Okay, these are the things that we reviewed, that we talked about that so far, was somehow a review of the concepts of a function. And essentially to talk about that, why do we need the functions? Sometimes you may ask yourself, what is the reason I'm taking two different courses at the high school? One of them is going to be the function, and the other one is going to be the advanced function. Then at the end, I have to just talk about, take another course, which is called the calculus, which is extension to the functions. Then you may have a partial answer that the functions, they allow you to do two things. First, represent something. For example, in the example of my income, for example, let me write it here. For example, the functions benefits, which is going to be the thing that we learned before first. First is that it allows you to represent an event. That's what we talked about it as a modeling. For example, in the example which I had about my income, based on the hours which I teach you, you saw that you were able to use very simply represents my income. Second, it allows you to predict what happens in future. Doris, is it correct? That's what we saw at the second example. That we saw that how the model which I provided, it allows me to see what is going to happen in future. For example, at the end of the month, my future wasn't too far. I looked at the future in a month, that what's happened at the end of the July, how much income I may get. Okay, at the end of, let's say, at the end of the month. That's two things, which is why you are studying the functions at the high school. These are the two things. That's it there. And now we are moving on to do some new stuff before we take the break. These things are going to be something new, which is essentially the thing that it's going to be for the concepts of the advanced functions grade 12. Okay, let's see. I'm going to draw something. Let me see if I'm successful for drawing a Cartesian plane by, oh yes, that's so impressive, guys. So impressive, because I didn't know I can just draw the Cartesian coordinates by these ones. I'm so impressed. Okay, look at that. I have a Cartesian frame. Look, it's the vertical axis. It represents my f of x. This one represents my x. This one is my f of x. Maybe this one, which it shows the direction, even it's square. Let me, sorry guys, I'm experimenting some stuff. Yes, now it's way better than we have Cartesian frames, which it has the axis. Okay, now we have a Cartesian frame, which I showed that here for you. And now we are going to, let's say, do something. Guys, I'm going to go back to the example which I had. I'm going to show that to you. Okay. The same model that I showed that to you for my income. What was the income which I showed that to you? Y as f of x was 10x plus how much? Plus 5. Then if I want to, that's a linear function. If I want to plot it in this function, it becomes something like that. Correct? Okay. This one is going to be 5 plus 5 because that's essentially the intercepts, which means that if even I do not work at all, I work for 0 hours, you see that it's going to be the income which I get is going to be $5. That was the interpretation which we made about that. The $5, it becomes my intercepts, and you see the linear representation of my income. I'm going to ask you questions for everyone in the class. Can I plot also to the left? Can I continue the plot to the left? If Y represents my income and X represents the hours which I worked, can I plot the functions like that? I mean the red color as a tail of the plot. Can I do that? Any answer? Lara, Sylvia, Anki? Do you think I can do that? Guys, if you are there, please say your name.
Say my
Just Laura is there?
I'm here too.
It's here.
Okay, thanks. Then guys, what do you think? Can I represent the plot like that? It goes all the way down there. The blue color, that's the first plot which I made. But this one, how about this part? Is it correct? I say it cannot be correct because why? Because when I look at this one, I say, okay, X represents the hours which I worked. Left side of the X represents what? Still the hours, but they are negative. For example, if I'm gonna stay there and it becomes -4, it means that I worked -4 hours. Does it make sense? I know I can work for 4 hours. It's a positive integer. But when someone comes and talks, I just worked -4 hours. It doesn't make sense at all. Does it make sense to you guys?
Yes.
Doesn't. Then as a result, you see that this part of the graph is not correct. Then I have to erase it. Oh, also I erased, I should say, my axis for the y. Okay, it's gonna be my y. Okay, now. And the only thing which is gonna be correct, then this part of the graph is gonna be correct. And the other one was not correct. And that's why we love it. I'm just using some of the symbols which I have on the Zoom, like the heart or those kind of stuff. Okay, and now the question, guys, is that I'm just gonna find something. We are gonna do something very, very crucial. Then I need 2 minutes. Then we can go for the break. Normally, we are gonna take the break after each 45 minutes. Today, sorry, it got a little bit long, but I'm just gonna finish it very quickly. Then we can go for the break. Guys, look at this part. Let me change the colors. I change the colors which I have to green. Imagine I worked for, let's say, the first 2 hours which we talked about that. If I work for 2 hours, x becomes 2. How much is going to be the y? It means that you go all the way up there, then you go there. How much is that going to be? It's 25, right?
Yes.
Y is 25. And also, if, let's say, imagine that I measure all my income, then I teach you, for example, let's say 8 hours. How much income do I get?
85.
That's so true. I get 85 hours. Then it means that if I write here x as equal to 8, y, which represents my income after teaching 8 hours, becomes $85. Okay. Now, guys, how much change did I have? The rate of the change, that's something that we're going to talk about that today as the new lesson, which is going to be for today. That's what we call that as a rate of change of a function. That's essentially, that's the lesson that we are going to learn it today, which is called the rate of change of a function. The rate of change of a function is what? In this example that we have. How do we define it? You have seen that before. When you were writing, I should say, the finding the function of the rate, the linear representation of a function. We said that what is the rate of a change of a function? Previously, in this example that we have, I call that, let me change the color to this one. Well, how do we say the rate of the change? With the change, guys, remember, always we show this one. This is a triangle. You see this triangle? For example, this is a triangle, and I show that next to an apple. It means that the rate of the change of the apple which you are eating. Are you eating the apple so fast? Are you eating the apple so slow? For example, Sylvia, Anki, and Laura, do you like apple?
Yeah.
Yeah.
Yes, awesome. Imagine, guys, I give to every one of you one big round red apple. Each one of you start to take those apples, eat them, munching, Then imagine that each one of you, and we just run a competition to see who eats and completes the apple first. For example, Anki is gonna eat the apple much faster. Laura is gonna be the moderate one. And Sylvia, imagine, eats the apple slower. You see that the speed that you are having your apple is different. Am I right? Yes? And that's what do we mean by this. When I show that to you, this symbol, the delta of apple, it means that the rate that you are eating your apple. Then if I come here and write delta y, which y represents the total income which I'm having from my teaching, it means what? It means that the rate of the change which my income changes becomes y2 minus y1 corresponding to x2 minus x1. This is the grand formula. For my special case here, y2 is going to be this 85 because that's the second change. Then it becomes 85 minus y1. What is y1? 25 divided by x2 minus x1. What is x2, guys? Eight minus 2. Correct?
Yes.
How much is that? The total. 85 minus 25. How much do you get?
60.
60, correct. Thank you. And how much is 8 minus 2?
6.
6. Fantastic. Then how much is total?
10.
10. Fantastic. Superb, superb, really. Look at, guys. I'm gonna finish with one word, then we go for the break. I'm sure you cannot wait for it, huh? Look at this. I have 10 here, which it is what? It is the rate of change. What do I mean? I mean that delta y equals to what? 10. That's what I got. But also at the same time, remember, we have to add it. I'm just going to go, when we come back from the break, I'm just going to give you a bare representation. But remember this 10, that's the thing that we just got. Delta y over delta x is 10. Then when we come here, we write this. What does it mean? We said we drive delta y with delta x. We got how much? 10. And I'm going to finish in 1 minute with this word. When we come back from the break, we are going to expand on these concepts. Guys, look at that. What do I interpret this one? Because interpretation of the rate of the change is going to be very crucial. I mean, how do I define it? Guys, what y represented? My income, huh? And x represented my hours, correct? That I teach. And you know that from the things that you have learned, you can always add the denominator as 1, correct? This one, what does it mean? It means that when you get the rate of a change of a function, it means that for each unit, look at 1, it means 1 unit, huh? For each change of your variable x, your dependent variable, which is y, changes by 10. And that's what it means. I'm going to write it here also, please. You make sure that you just type the same thing which I write. The interpretation is this. For the change of each unit of the, we call x as, let's say, independent variable. The dependent variable, which is y, changes by 10 unit. Guys, please make sure that you also write the same thing which I have written here, because let me, oh my God, What did I do? Let me redo this. Okay. Let me undo. Okay, no worries. Let's bring it down there. And look at that. That's going to be the interpretation of the thing that we did today. When we come back from the break, we're going to talk more about this. But for today, that's what we do. Based on the thing that we represented, delta y over delta x, if this is 10, it means that by every single change of the unit of delta x, your dependent variable, which is my income, changes by 10. It means that for every 1 hour which I teach, I get $10 change on my income. Does it make sense, guys?
Yes.
Awesome. And that's essentially what we are going to end the first half of the class with. We take 15 minutes break. When we come back, we'll be trying to finish what we learned today. Any questions, guys, so far?
No.
No? Laura, Sylvia, and Anki, no questions?
No.
Awesome. Guys, take 15 minutes break. When we come back, we have something extraordinary to do, something amazing to do. Please take a good break. Come back by 12:15. We just continue by then. Please be on time. Okay. See you guys in, let's say, 15 minutes. Please be back by 12:15. Okay, guys?
Okay.
Awesome. Enjoy the break then.
Yeah, I'm here.
Yes.
Fantastic. Okay. Now, there is only one point which is left to talk about that essentially we are going to be done with the content which I prepared for today. And that thing, any questions, guys, by the way, guys, from the things that we talked about that in the past? No questions? Okay. Let me show the Cartesian coordinates. Okay. Everyone's ready now to continue? Okay, guys. There may be only a need for 1 or 2 minutes that we can start. Then what did we do? Okay, let me the previous function that we talked about, and as you saw that we talked about that, it was a linear function. It means that we represented that function by a graph, and the graph of that function was a simple line. That's why one of the methods, one of the ways we call a function linear, we look by looking at the graph. And now imagine that I have a different representation of a function. Let me change the color. Let me change the color. And imagine that that's gonna be a function. For example, let me give a better shape to that function. It's a little bit absurd. Okay, look at this function. That's a quadratic function. Okay, look at that. For example, I come here, I show that this is going to be my function f of x. It can represent anything in nature because when we talk about the functions, they can represent some events in the nature. It can represent anything, and that's a quadratic function. We saw that we can just choose 2 points on that function as what you saw before. We saw that, okay, this is going to be, for example, 1 point, here, I choose that point. When I make projections to the x-axis, I get point x1, and projection to the y-axis, I get the point f of x1 or y1. And also, I'm just going to choose a different point here. Okay, it's going to be called point x2. And it's going to show that, for example, the projections on the y-axis, it represents f of x2 or y2. And guys, imagine that based on the money which I earn from here, okay, this function which I showed that to you here, this function f of x represents my growth in saving in the bank. Growth in my saving. I have money in RBC Bank. For example, I have money based on the income which I got from this school. I saved some money into the bank. And this line here, which you see, the function represents the growth. For example, x1 represents my total saving at year 1. x2 here represents my total saving at year 2. Does it make sense to everyone now?
Yes.
Yes. And now, you see, my money is increasing. For example, year 2, for example, I have higher income, higher saving. You see that? Yeah, compared to the year 1. And now, that's the thing that becomes very tangible. And now, look at that. The way I'm just going to look at that, I ask myself the question, very important question. How fast I'm getting rich? Do I have to wait until I'm 80 years old to get rich based on the return which I get from the RBC Bank? Or no, at the age of 40, I can retire, I have enough money. That's, look at the expression which I said. I ask myself how fast I'm getting rich. Everyone, do you understand the concept? Yes?
Yes.
In order to answer that question, that how fast I'm getting rich, I come to answer that by only a simple mathematical formula. And that's going to be this. The formula is this. I say delta y over delta x, which it represents the average rate of change. That's what we talked today about that. But that simple ratio, look at that, that's what we call that a ratio. It means the fraction. We call that a ratio. It's a simple fraction, delta y over delta x, is gonna answer the question that how fast I'm gonna get rich. Becomes y2 minus y1 divided by x2 minus x1. For example, y2 can represent $1 million, the total saving which I had. Y1 represents, for example, $50,000, and x2 minus x1, it becomes what? It becomes, for example, only 1 year, between the first year and the second year. Okay. And now, this ratio, which we are going to get, I'm going to call that, for example, A. For example, imagine if, for example, Laura, you said that you want to do business, huh? Laura, imagine that that year 2, your income from the bank is gonna be $2. But for example, in year 1, it was $1. Within a year, your income is doubled, huh?
Yes.
That's right. And now you see that the A, which represents that rate of change, is positive, huh?
Yes.
And that's what it means, the growing function. The rate of change is positive. It means that you are getting richer and richer and richer. If I have, for example, as a rate of change, I have A1, which is less than A2, which is less than A3, which is less than A4. A4 is the higher rate of change. Which rate of change you prefer in order to become richer?
A4.
That's right. You pick up the bigger one because with the A4 you become richer faster. At the age of 30, you can retire because you have all the money which you needed. And that's, we call that increasing function. The rate of change for that function is represented by that. Also, before I just go to the next slide, I can show you something, for example, here. We saw that, for example, within these 2 points, between x1 and y1, and x2 and y2, I can draw a line, right? I can connect these 2 points of my interest. These 2 points are my interest. Then I connect them with the line, and you will see that later we call that line a secant function. We call this function a secant line that connects these 2 points of interest by a straight line. The slope of that line, if I call that y equals to ax plus b, which is the line of a straight line, you will see that the slope of this line is essentially the thing which you have earned as a rate of change. And you can connect it that the slope of a function is essentially the slope of a straight line is essentially can be interpreted as the average rate of change of your variable with respect to, let's say, the predictor. Any questions, guys?
No.
No? Silva, you still have a question? Okay. I go to the last point of the course today. And I'm just going to see, okay, what may happen with a different scenario? Imagine I'm just going to go to invest my money in a different bank. This bank gives me the income like this. It means that, for example, it becomes my f of x, my total income. F of x, it may represent my income, my saving in a different bank. Saving in, let's say, for example, oh, what happened? Something crazy happened, sorry. It becomes, for example, my saving, let's say, in a different bank. For example, in TD Bank. For example, you see that, for example, at the year 1, which is x1, I have this much income, y1, but after 3 years, for example, at x2, my total income becomes lower. Am I right? It becomes smaller. It means that my income did shrink. And Just, Laura, did I benefit? Did I profit or did I lose anything?
Lose.
That's right. I lost my money. Then I come here, say that the delta y, the delta x, these very interesting, guys, you cannot believe that. This simple ratio, it has a huge impact on the mathematical analysis. Becomes y2 minus y1 divided by x2 minus x1 becomes something as a, which a is positive or negative? Becomes negative, huh?
Yes.
Which it means that in that scenario, the rate of change, for example, it means that for any change in your x, which is gonna be year, it means that for 1 unit change in the x, it means that if from year 2 you go to year 3, from year 10 you go to year 11, your income is being reduced by a. For example, if you get a, let's say, for example, 1,000, it means that after each year you are losing $1,000. Does it make sense to everyone?
Yes.
Yeah. And now we come here, we connect these 2 points together as a secant line, which you can represent it by ax plus b. You know that a is what? A is negative. Am I right? A is negative. Then if you had, for example, a1 less than a2 less than a3, no, let's not confuse with that one, because I had to talk to you about the absolute terms of them. Then it becomes not it makes it confusing. I don't want to make it confusing at this stage. Then I do not go that to the comparisons, because I need to talk about the absolute values, not at this stage, but that's essentially what we talk. Recall that the negative slope, we call this one, let me write, let me text here, we call this one negative slope, which represents the decay or decrease in the function for a unit change in x. Okay. Does it make sense, everyone?
Yes.
Awesome. Fantastic. Fantastic. Okay. Now, essentially, that's what we are done essentially by a simple demo of the class lesson for today. I think that's for today. That's going to be a good portion of the thing that we just wanted to have. Okay. And let me stop sharing that thing, and let's see what can we do. I'm gonna share, guys, any questions so far? No? Lara, Sylvia, and Anki? Any questions?
No.
No? Okay. And now, before we move on to the next task, I'm just gonna show you the content in the book, which you need to cover it. Okay. Guys, if you please go to the textbook, I shared the screen in the textbook, and essentially, you have the screen. Everybody see my screen?
Yes.
At this page, which is chapter 2.1, I'm just gonna post that on the course story, that what is that? You see, that's essentially the idea that we talked about that. For example, you saw we talked about the average rate of change. It's written as a change in y with respect to the change in x. And that's the formula we drove. And that's the graph of the secant line. The red one is a secant line that we talked about that. Huh? Then essentially, the thing that you are going to be good with that is that if you go to the homework, which is going to be the assignment for today, the practicing, you see, there are many simple stuff that you can just work with it and just do learn your knowledge until chapter 2.2, which is going to be, that's the thing that we covered today. And that was pretty much everything that we needed to learn today. And please remember, for the homework, don't forget all the assignments for the chapter 2.1. I'm just going to also post that on the Schoology website. And that's the lesson for today. Any questions?
No.
No? Okay. And now, there is one more task to do for today. Guys, because we are going to change the gear now, we are going to change the gear for something different. We need to relax our minds and take a deep breath, do some exercise, because the next task is completely different than the first one which we did. Then I want to give you the chance to refresh and to grab something, come back, to change your mind, change the mindset, come back. I'm just going to give you 3 minutes that you step away from your desktop, just go drink your water, do some exercise, come back in 3 minutes. We are going to do something completely fun, completely different, and very exciting. But I need your mind to be free. Okay? Please take 3 minutes, come back in 3 minutes, then we start. Okay?
Okay.
Please